Welcome to e-Adhyayan Commerce. Today we will understand mean median mode. Mean median mode are the central tendencies of a data set. They give the mid value or the central value of a data set. Now why will we understand the central value? Because it is a very significant factor. Central tendency is a single representative value of the data set that shows the midpoint of the data set. So it is a single representative value that shows the midpoint of the data set. Now this single value, it summarizes the scattered data set into a concise, understandable figure. By the help of this central tendency, we will be able to compare defined data sets as well as predict the trends of the data set. Also, it helps us to detect the extreme outliers, that is the extreme values in a data set. Central tendency summarizes the entire data set, and from that we will be able to understand the underlying structure and the features of that data set, and from that value we understand the appropriate analytical approach that is required to understand and make absolute predictions about that data set. So from the central tendency or the central value, we get the summary of the entire data set. From there, we understand underlying structure and features of the data set, and from there we understand the appropriate analytical approach to make predictions. So three things: that from the central value we get the summary of the data set, okay, that we are getting the summary of the data set. Then understanding the underlying structure of the data set and the features that the data set has, and from there the appropriate analytical approach that helps us to make predictions about this data set, to make prediction. So central value that gives summary of the data set. From there you understand the underlying structure and the features, and then from that we get the analytical approach to make predictions about it. So this goes everything about the central tendency. Now that we have understood the central tendency, we'll understand mean median mode one by one. Mean is the most popular way of calculating the mid value of a data set. It is also called arithmetic mean. We can calculate it by adding all the values in a data set and divide that the number of observation in that data set. So it is really very easy to understand that we have to sum of all the values in a data set and then divide that with the number of observations in that data set. So now mean we can segregate in three types. There are three types of mean. The first one is arithmetic mean. The second one is geometric mean. And the third one is harmonic mean. So there are three types of mean, that is arithmetic mean, geometric mean and harmonic mean. In a very simple way, we will understand each of them. Arithmetic mean is similar to mean. We also call mean the arithmetic mean sometimes because it's the same thing as mean, that sum of the values of a data set divided by number of observations in the data set. When we will give an example of it, then it will be clearer. Example number A. Data set 1, 3, 5 and 7. So there are 4 values. So first of all that we need to do is the sum, that we need to add all these values. Okay, that is sum of values would be 16, and here the number of observations, the number of observation is 1, 2, 3, 4. So there are 4 observations and the sum of the values is 16. So now the mean or arithmetic mean will be simply the sum of the values divided by the number of observations, that is 4. So 4 would be our mean or arithmetic mean. Now in a different example, here we had 4 values or even values. Now say in a data set we have odd values, that the total number of values in a data set is odd. Let's say 2. Okay, something like that, 2, 3, 5, 7, 8. Now the sum of the values here would be 25. Okay, and the number of observations is 1, 2, 3, 4, 5. So here the mean or arithmetic mean would be 5. So this is how we calculate the mean, that is the arithmetic mean, in practice. Now we will move on to the geometric mean. Geometric mean is the positive nth root of the product of the values of a data set. So we will have a note of this, that is the positive nth root, the positive nth root of the product of the values of a data set. Okay, so the positive nth root of the product of the values of a data set. Now we will understand it with an example. Say the data set has these values. So in order to calculate the geometric mean, we will need to multiply them, and the nth root, nth means that the number of observation, in this case it is 3, 1, 2, 3. So the positive nth root, so we will be rooting with, the nth root, and here the n is 3. So the product would be right. From that we get right. Sorry, no, it would be okay. From that we get, so this is the geometric mean that we have calculated, that is 4. Now we will understand harmonic mean. Now the harmonic mean, that is also a type of mean. Here we sum up the number of observations in a data set and then divide that with the sum of the reciprocal of the values in a data set. So sum of the observations of a data set, that is divided by the sum of reciprocal of the values of that data set. So first of all, we need to see that the number of observations, like 1, 2, 3, 4, 5, then we have to divide that by the reciprocal of each value of that data set. We'll see that with an example. Let's say the data set okay, so the number of observations in this case is 3, 2, 6 and 12, 1, 2, 3, so 3. And now you need to find the sum of the reciprocal of these values, that is sum of reciprocal of the values. Okay, that would be 1 by 2, that will be 1 by 6 and 1 by 12. So in every occasion the values are converted into their reciprocals. So for the understanding of it, we will do it together. Okay, is the harmonic mean equals to 3 number of observations divided by the reciprocals, that would be this. So after doing the LCM would be 12, then that will be 6, 2 and 1. So this becomes 3 6 2 plus 1 is 9 and 12. So that be 12 divided by 9 into 12. Okay. So if we make the calculations, it would be 4. So again, the harmonic mean is 4. So that is the understanding of arithmetic mean, geometric mean and harmonic mean. Median is the middlemost value of a data set after it has been arranged in a numerical order. We can arrange it in ascending or descending order, but the middlemost value becomes median. Okay, now we have to note it down. So the value in the middle of a data set, after arranging it in a numerical order. So if we give an example of it, okay, let's say here the middlemost value is 10. So it is the median of this data set. But in this example, if you see, the number of observations in this case is even. It is 1, 2, 3, 4, 5, 6. So there is no midpoint. If we see, there are 3 values in the left, also the 3 values on the right of it. So then what we will do, we will take these two, 9 and 12, we will add it, 9 plus 12, and then divide by 2. That would be 21 by 2, that would be 10.5. So in this case, when the number of observations in a data set is even in number, then we take the two middle values, two mid values, okay, in this case the third value and the fourth value, then we add it and divide by 2, and in that way we get the median, that is 10.5 in this case. Okay. Mode is a value of the data set that occurs the most or has the highest frequency. So let's note it down, that mode is the value of the data set, either A, that occurs the most, in case of non-frequency data set, or has the most frequency in a frequency data set. Okay, so either it occurs the most, okay, or it has the most frequency. Now we'll also understand it with an example. Data set like this. So you can see, and that is, first of all you need to arrange it in an increasing or decreasing order. In this case I am doing it in an increasing order. 2 done, okay, another 2 is there, so 2 is done. Any other 2s? No. Then 3 done. After that here is also in 3 done. Okay. Any other 3s? No. So the 4, yes, another 4 is there, another is there, and there is also another one. So there are 4 4s After that there is 5 5, so 2 5s, and then there is 2 6s. Okay, there is 2 2s. Okay, first of all I write it as values. You will understand it. Okay, 2 has 2 times, 3 also has 2 times, 4 has 4 times, 5 has 2 times, and 6 has 2 times. So the most occurring one is 4. So that would be the mode of the data set. Okay, on a different example, in this time we'll have the frequency. Let's say there are 4 classes of students in a class. They have scored between 0 to 10, 10 to 20, 20 to 30, and 30 to 40. So from 0 to 10 there are 3 students, from 10 to 20 there are 5 students, from 20 to 30 there are 8 students, or 30 to 40 there are 2 students. So in the class of 20 to 30 we have most number of students in the class. See, 3, 5 and 2, and then there is 8. So that is, in a frequency distribution like this becomes the mode. Okay, that is the brief understanding of mean, median and mode. Now we will talk about some important factors related to mean, median and mode. There is an empirical relationship between mean, median and mode. Now, before understanding the empirical relationship between mean, median, mode, first we need to understand what do we mean by the word empirical in statistics. Empirical simply means that there is a correlation that has been observed through data and experiment. So in a moderately skewed distribution there is an empirical relationship between mean, median, mode. That is, that a correlation has been observed between these 3. Okay, and the empirical relationship between mean, median and mode is so in a moderately skewed distribution, mode equals to 3 median minus 2 mean. So that is the empirical relationship between mode, median and mean when there is a moderate skewness in the distribution of the data. Now we'll also understand the skewness of a distribution, and from there we'll understand the relationship between mean, median, mode in a symmetric and non-symmetric distribution. Now we understand that mean, median, mode in a symmetric or non-symmetric distribution, that is also called skewed or non-skewed distribution. But in order to understand that, first we need to understand the skewness. Skewness is simply that is how unbalanced a data set is, that is the lopsidedness of the data set compared to a normal distribution. Okay, so we'll see that the relationship between mean, median and mode in a non-skewed distribution then comes in a positively skewed distribution, as well as in a negatively negatively skewed distribution. So in these three distribution, we'll see the relationship between mean, median and mode. In a symmetric non-skewed distribution like this, the mean, median, mode falls in the same line. Exactly like this. In this point, mean is equals to median equals to mode. So in a symmetric non-skewed distribution, that is normal distribution, the mean, median, mode falls in a same line. Okay. In a negatively skewed distribution, the mean is the smallest value. It lies here. Median is bigger than mean. That is median, I am writing it above. And then comes mode, is the largest one. So in a negatively skewed distribution, mean is the smallest, then comes median, and the largest is mode. That is so the mean is the smallest one and the largest being mode. Okay. Then we move on to, in a positively skewed distribution, the mode comes first, is the smallest of all. This goes mode. Then comes median, writing it above again. Then comes mean. So in a positively skewed distribution, median is greater than mode and mean is greater than median. So mode is the smallest one and median is the largest one. Now we will see the things that affects mean, median, mode. First of all, if we change the origin, that is, if we add or subtract something to the values of the data set, let's say data set having these values. Okay, here the mean would be, in this data set, the mean would be 4. But now if we change the origin of it, say you add 1 to each of the values, the 2 becomes 3, 3 becomes 4, the 4 becomes 5, 5 becomes 6, and 6 becomes 7. So now you see, now the mean will be changed. Okay, that would be 5. So mean, median and mode, 3 of them are affected by the change of origin. So yes, 3 ticks. Now if we see the change of scale, that is, you are either multiplying or dividing the values. In this case, we will multiply it with 2. So the 2, the original value of the data set 2, 2 becomes 4, 3 becomes 6, 4 becomes 8, 5 becomes 10, 6 becomes 12. So now in the revised data set, the mean is 8. Okay, the central value is 8. It has been changed. Originally it has been 4, now it has been 8. So mean, median, mode, 3 of them also affects by the change of the scale. Now you see the extreme values. The extreme values is not much important in the case of mode. It does not get affected by the extreme values. So here it will be straight no. the median is slightly affected. Okay, by the extreme values, the median is slightly affected. But if we are talking about the mean, by the changing of extreme values, mean is highly affected. Because the fact is that mean is based off all the observations in a data set, that is median and mode is not. So these are the things you need to have in mind to understand mean, median and mode. I hope I have helped you understanding mean, median, mode in a better way. I hope to see you in the next video. Thank you.